Welcome to another week. So tomorrow we are going to give our third internship rotations, the last ones, and therefore I'm still trying to do the last analysis here. Hopefully I will be done with that by end of today, and then I will help Noah with his analysis.
Doing this same thing, but instead of using a chi-square, can we use a mixed model to compare those two numbers?
Yeah, I think so.
Acquisition, where trial equals.
After that we gave some practice presentations to each other in the cohort, and now I'm on my way to instructing my undergrads for what they shall do this week. Presentations!
And the next rolling.
Time-tested technique called the proboscis extension reflex method. And I'll play the video in just a second. Super fun. These antennae with sucrose here on a toothpick, they reflexively extend their proboscis. Just to look it up, it's actually insanely cute.
For taking the time to show up and participate in this ritual, this EEV ritual. Our 3 PhD students here have now jumped through this hoop, and let's give our congratulations to them.
I forgot recording myself giving the presentation, so I thought I would give you just the short version of the presentation, which was only 7 minutes now, so if you are interested, if not, you can skip ahead. I was looking at how leaf cutting and nest mounts influence which plants or trees can grow on them. So first, as a background, until about 10,000 years ago, the end of the Pleistocene, there were a lot of big mammals, a lot of herbivores, so plant eaters, on the whole world, like this giant sloth. Then humans spread, and that's probably why a lot of those super big animals went extinct. And so now in the Americas there were no big herbivores left. And this is why now there are the leaf-cutting ants that are the major herbivores in the tropics and subtropics of the Americas. And these ants form huge colonies. In the picture on the right you can see an excavation of one of these huge, massive ant nests. And these have more than 1,000 chambers and up to 8 million workers at a time. So you can imagine that they can do a lot of damage when they cut the leaves here and transfer them to the nest, where they then process the leaf fragments into substrate for the mutualistic fungus that the ants then will eat. So the impacts are, of course, direct by just leaf defoliation, and they also carry away quite a lot of the flowers of the trees. They make these trails, they cut away any vegetation that will pop up on their nests, and they will also cut any roots that grow into their chambers, because of course they don't want them there. So they take a lot away from the plants, but they also don't really give anything back, because they store their waste deep underground where the seeds can't really access those nutrients in there. And yet there are still some trees that actually grow on these nest mounds. So I wondered, what are the traits that these trees have? What makes them grow on there? And I couldn't really answer it in a holistic way, and I just looked at 2 traits basically. So a trait is a character of any organism. So I looked at that in a plot in the Costa Rican deciduous dry forest. And here I compared trees that are growing on the nests versus growing somewhere in the forest on a random plot. And you can see that, of course, there are fewer numbers of plants growing on nests, which is expected, and also the species number is lower. There's no difference between the size of leaves between plants that are growing on the nest versus off the nest. However, there is a small difference in the specific leaf area. And this just means that the leaves are thicker or denser on the trees that are growing on the nests versus off the nests. And this is interesting because we know that leaf-cutting ants try to avoid cutting very sturdy and thick leaves, and they prefer the softer and thinner leaves. So that might be a reason for why we see this trait of these trees to be more prevalent on nests than in the forest. So this is just one trait that can help a tree to grow on the nest site and not being cut by the ants. So it would be really interesting to look at all sorts of other traits like seed size or any chemicals that might be stored in the leaves. yeah, but that is something for future work. I just saved 26% off of my grocery list because my grocery store just sent me these coupons. Some of them are really awesome, like get one for free. It's just because I'm a regular customer and I always buy the same 10 things or so. They send me these customized coupons so I can capitalize on them. That's $11, that's a lot. So about 2 weeks ago I sent an email to the HPC, which is the supercomputer that the university obviously has. And yeah, every researcher can run some experiments or whatever, simulations on these computers. So I asked them whether I could, do some analysis of the videos on their computers, and back came like immediately maybe 5 emails or so from different people and yeah, with suggestions of how to do it, how to make it work in the best way. We went back and forth, so it was like overwhelming how much support I get. And yeah, now is the day that I will meet up with them and discuss a little more in depth how that could work. So I would have to upload my videos to their server, and then they can run my MATLAB script on their Linux servers, and that would then take maybe 45 seconds instead of 45 hours. Wrong building. This is the right one. That was a lot of information, and great information. I think I almost kind of know now how to do it. Should be great. Now rushing to my class that started already a half an hour ago, so yeah, it was worth it. Hello, it's St. Patrick's Day. This is why I'm in partially green. I wanted to go downtown to the parade, but yeah, I'm still in the lab. I talked to Chris, one of my undergrads, about coding R and stuff. And I'm thinking more and more about optimizing the workflow of going from 4x4K video data to just a list of X and Y coordinates of the ants. And one thing that I'm going to do with the HPC is probably minimizing data file size. Now I'm trying to head downtown. I will head downtown to get a little bit, like maybe the rest of the parade and some of the other stuff that's going on there. Yay, American culture. I was a little bit late, but now I'm hitting the bar scene.
And they're all local Tucson whiskeys here.
Yeah.
So I'll take a little sippy sip of this one.
Morning. Okay. Yeah, I'm really excited about learning all the stuff about videos and supercomputers and programming, and also reading papers about how to analyze trajectories of moving things like animals and cells and all the math behind that. The theory is super interesting, to me at least. And I've never been a mathy guy. So yeah, I hope you enjoyed as well, and see you next week.